Hi everybody. So this next section is probably one of the hardest lessons in the whole course, and it has to do with inverse functions. And it's part of it. The name is kind of unfortunate because you think like when you're taking the inverse of something, maybe you might think you're taking the reciprocal of something, but that's not at all what we're talking about when we're talking about inverses of functions. Now, before I give you the exact definition, let me just give you just a real crash course on this. Probably the easiest way to explain inverses of functions. So, if you have like a function, let's say here's 1, 2, and 3, and here's 4, 5, and 6, and let's say you have a function f that takes 1 to 5, 2 to 4, and 3 to 6. Okay, so algebraically, what we would say is f of 1 equals 5, f of 2 equals 4, f of 3 equals 6. Because that's a function. The inverse function is basically the same thing, but with the arrows reversed. So 4 would go to 2, 5 would go to 1, and 6 would go to 3. Okay, so whereas f of 3 is equal to 6, we see that f inverse of 6 is equal to 3. Okay, so the inputs and outputs are basically interchanged. That's what we mean by the inverse of a function. Okay, now sometimes there's some nice formulas involved, sometimes there isn't, but that's the idea. Now, the thing here is that if you start with 1, you apply, let's say you apply f and then f inverse. So if you apply f to 1, you get 5, and then you play f inverse to 5, you get 1. Okay, so you get back what you started with. Similarly, if you started over here, if you started like say 6 and applied f inverse, you get 3, and then you applied f to 3, you get 6. You get exactly where you started with. So that's how we get this definition, is that if f is a function, that we basically, if two functions are inverses of each other, that means if you compose them in either order, you get the same element you started with. That is, f of g of x equals x for all x in the domain of g, and g of f of x equals x for all x in the domain of f. Now we have to make a little more, or we should say really make a little minor addition here and say this is where it makes sense, because we need g of x to be in the domain of f and f of x to be in the domain of g. Okay, but basically these are two functions are inverses if they're inverses with respect to composition. Whereas if you compose them in either direction, you always get x. You always get what you started with. And then some functions have inverses, some do not. If a function does have an inverse, it's invertible. And we use this notation that is f to the minus 1 of x. That's supposed to be the inverse of f. So this is unfortunate because we just got telling you how to treat negative exponents. And you say, okay, if a is a number, then a to the minus 1 is 1 over a. But that's not the case with functions. Okay, this minus 1, we're not really raising anything to the minus 1. We're just saying this is the inverse function of f, and that's all it is. Okay, so it's not the reciprocal. And the way to keep this in mind is that f of a equals b if and only if f of inverse of b equals a. Okay, that's really how you really want to think about inverses of functions. Okay, the inputs and the outputs are exchanged. So, for example, if f of 14 equals 207, what's 207? F inverse of 207? Well, this would just be equal to 14. We don't know anything else about this. We don't have to know anything about this function f except that it's invertible and that f of 14 is 207. Now, obviously, we couldn't, if you wanted to find f inverse of some other number, we'd need more information, right? But this is okay. If we know what f of 14 is, f of 14 equals 207. The opposite of that is f inverse of 207 is 14. So let's do just a few examples here. So we have, let's say, if we wanted to find, this says here are the values of x. F of 5 is 6, so that means f inverse of 6 is 5. F of 6 is 8, so f inverse of 8 is 6. F of 7 is 9, so f inverse of 9 is 7. F of 8 is 7, so f inverse of 7 is 8. And if f of 9 is 5, then f inverse of 9 is 5. So everything is reversed. Okay. All right. Now, let's say we know what the formula for a function is. Okay. And we want to find out, in this case, if f of x is given by 2 times 3 to the x, what is f inverse of 2 and f inverse of 6? All right. Now, that might be a little harder because we don't have, we're not given anything else. But let's think, what does this mean? F inverse of 2. Well, if f inverse of 2 is equal to a, let's say, this is equivalent to saying that f of a is equal to 2. And in this case, that would mean that 2 times 3 to the a is equal to 2. Okay. So what value of a works? Well, I think you can see we can divide both sides by 2, and we'll get 3 to the a is equal to 1. And we know that any number to the 0 power, any non-zero number to the 0 power is 1. So we can just take a to be 0. Okay. So that means that f inverse of 2, in fact, is 0. Okay. If we wanted to find what is f inverse of 6, we could do the same way. We can say f inverse of 6, if we call that, let's call it c. This is equivalent to saying that 2 times 3 to the c is equal to 6. And once again, we can divide both sides by 2. We'll get 3 to the c equals 3, and you can check that c equals 1 is what works. Okay, so we can see that f inverse of 6, in fact, is 1. All right. Okay. Let's look at another example here. In example 4, here we're just given the graph, and we're given some points on the graph. Okay, so let's see what can we do this now. Here, this is the graph of f. Now this corresponds, every point on the graph of f corresponds to an equation. It tells us what the value of f is at a certain point, namely the x coordinate. So if this point tells us 6, 5 is on the graph, that means that f of 6 is equal to 5. This tells us that f of negative 7 is equal to negative 5. Okay. Well, what about this point? This point, that the x-coordinate is 4, so the y-coordinate, and we're on the x-axis, so the y-coordinate is 0. So this tells us that f of 4 is 0. And this here, at this point, the x-coordinate is 0, the y-coordinate is 3. So this tells us that f of 0 is equal to negative 3. Okay. Now we can just flip these around. If we want f inverse of negative 5, well, we look and see where's the negative 5 is right here. So f inverse of negative 5 should be negative 7. F of 4 equals 0, so f inverse of 0 should be 4. What about f inverse of 4? Well, that is, let's see, that is, well, interesting. We'll come back to this. F inverse of 5 is 6, right? F inverse of 5 is equal to 6. And let's see, 4 F inverse of 4. This is, I think I screwed up because we can't find, we can't find any point where the y coordinate is 4, so let's not worry about that. And instead we do have one where the y coordinate is -3, and we can see that f of -3, that's why f of -3 is equal to 0. Okay, that's what we wanted to say. All right. Okay, I'm glad you watched that video. Okay. Now, note that this means if we these correspond to points on a graph of f inverse, right? This would mean that the point -5, -7 is on the graph of f inverse, right? And similarly, 0, 4 would be on the graph of f inverse, and -3, 0 and 5, 6 would also be on the graph of f inverse, whatever that graph is. And this is exactly what we have here. We basically, if we take a point on the graph of f, if we interchange the x and y coordinates, we get a point on the graph of f inverse. And that's why we get this result that says that if AB is on the graph of f, then BA is on the graph of f inverse. Okay, all this just reflects this says that f of A equals B. This says that f inverse of B is equal to A. So these are equivalent. And as a result, if you take all the points on this graph and then interchange the x and y coordinates, we get another graph here. And these two graphs are actually symmetric to this line y equals x, this diagonal line that cuts the quadrants neatly in two. Okay, so every graph is if a function is invertible, then the graph of its inverse is going to be symmetric to this. Now, the graph could still cross this line, but again, these points would have to be this acts as a mirror. Okay, this would be so if this graph crosses this line into here, this graph would have to cross down here. Okay, just to give you an example how this would work, if f of x is, we're familiar with this value, right? If f of x equals 2 to the x, if we plug in -3, we get 2 to the -3, that's 1/8. 2 to the -2 is 1/4. 2 to the -1 is 1/2. 2 to the 0 is 1. 2 to the 1 is 2. 2 squared is 4. 2 to the third is 8. So now if we were to find the inverses of all these, we would have basically just interchange, find the points on the inverse graph, we just interchange all of these. This is 1/8, -3, this should be positive 1/8, positive 1/4, -2, 1/2, -1, 1, 0, 2, 1, 4, 2, and 8, 3. Okay. And if we want, we could plot both of these graphs. Y equals 2 to the x. We know what that will look like, right? We know that we have a point 0, 1, and then we have 1, 2, and 4, and so on. It looks like this, right? Okay. So this is the graph of y equals 2 to the x. In this case, it would be f of x. If we plot these points like 1/8, when x is 1/8, that's right, and y is -3, that's going to be way down here. When y equals 1/4, that's still going to be very close to 0, but now we're at -2. When at 1/2, we're at -1, and then at 1, if we call this 1, then we're at 1, 0, and then we have a 2, 1, 4, 2, and so on. And so what's going on is the curve of the inverse is going to look like this. Okay, so this will be, we have the symmetric here, the symmetric thing going here. And this inverse function we are going to give this a name. We're actually going to see that this is a logarithm, an example of a logarithm, but that's in the next lesson. Okay, let's take a break right here, and then we'll come back for part 2 and finish up this lesson.